Hello and welcome to the 7-2 Notes. This is a section about similar polygons, and let's go ahead and let's talk about what similar polygons mean, or what the word similarity means. So I'm going to write the word similarity, and that means that things are proportional, okay? Proportional. Okay, and when I say proportional, I mean similarity. It really just means, in layman's terms, same size or same shape, different size. Okay. Okay, so an example of something that is proportional would be something like a globe. Okay, so an example of this, you see these things all the time, would be a globe. All right, a globe. All right, that is similar, okay, to the Earth. Okay, they're the same shape but different size. Okay, so they're the same shape, okay, but they're different sizes. Different size. Okay, like another example would be a toy car. Okay, an example would be like a toy car. Would be similar to the actual car. Okay, again, it's just this. It's the same shape. Okay, but different size. Okay. Okay, so I want you to notice something here, that I use this symbol, okay, this little squiggly line, to show that something is similar. Okay, so up here I want to write that we use the symbol. Okay, use the symbol. The squiggly line to show similarity. Okay, so let's kind of talk about mathematically what's happening here with similar polygons, and it's pretty basic. But what it means, okay, similar polygons. So up here, I'm going to write this. I'm going to put a little line here. I'm going to write similar polygons have these properties. So similar polygons. Okay. We know that all corresponding angles are congruent. So all corresponding angles are congruent. Okay, and we also know that the corresponding sides are proportional. Okay, so I'm going to come in here and I'm going to do a couple problems with you and talk about, numbers 1 and 2. Okay, so the directions say to determine whether each pair of figures is similar. If so, write a similarity statement and a scale factor. If not, explain your reasoning. So what I want to do is come in here and label things that are, label my angles that are congruent. That's the first thing that I want to do. So I know that angle A is going to be congruent to angle D because they're both 59 degrees. So I'm going to come in here and label that these angles are congruent. Okay, and then angle C is congruent to angle F. Okay, so I'm going to show that these two angles are congruent. Okay, and what I know, if two angles in two triangles, two pairs of angles are congruent, then I know that the third pair of angles is also congruent. Okay, and so I know that B is then congruent to angle E. Okay, so I do need to say a few things here. Okay, I need to say that angle A is congruent to angle C. I'm sorry, angle D. Okay, we know that angle B is congruent to angle E. Okay, and then we also know that angle C is congruent to angle F. And the reason why I wrote these out in this way, and the reason why I do want you to write these out is because this tells what corresponds with what, okay? What's in the same position, okay? So A corresponds with D, B corresponds with E, and C corresponds with F, okay? And that's because they're in the same position. And I can tell because of what angles are congruent with what other angle. So, angle A is in the bottom left corner. Angle D is in the bottom left corner, okay? It might not always be look just like this, but that's the idea. These shapes can be rotated and, reflected and translated, and, it's kind of hard to tell otherwise. So, but that's the idea. To write these statements out, help you to know what's corresponding to what. So I'm going to write this, okay, that I'm going to write that these correspond, okay, that these correspond. And they go either from, in both ways, okay? You can go from the left to the right or from the right to the left. So from the left to the right, you can look at it either way. This is also going to help me name, okay? This is going to help me name the polygons. Help me name the polygons. Okay, and that's important. Okay, because that's going to help us set up equations and stuff like that. So the other thing that I need to do, we showed that all of our angles are congruent, but we need to talk about if the sides are proportional or not. So what we've gone ahead and done, what we're going to go ahead and do is, because A corresponds with D and B corresponds with E, that means that AB corresponds with DE. And so it kind of just depends on how you want to go. Sometimes it's very specific, but I'm going to go from big to small. And so I'm going to write a proportion. Okay, I'm going to set up a proportion. And I'm going to say that 6, okay, in this, on this figure here corresponds with 4 here. So I'm going to put 6 divided by 4. Okay, and you can set these proportions up a number of ways. There's a number of ways to do it, but I also just kind of want to do it how I normally do it and how I think about it. We'll explore other methods here later. So I'm going to do, okay, so I've got 6 corresponds with 4, and then I know that BC corresponds with EF, okay, because you have these two congruent angles and these two congruent angles, and I'm thinking about what's in between those, okay? And so I'm going to set up an equal sign here, and I'm going to say going from big to small, I have the fraction 9 over 6, okay? And I just want to verify that these fractions are equivalent, okay? We can kind of look at it and say, all right, well, these, this is really 3 halves, and this can be reduced down to 3 halves. But we can also cross multiply and verify. Okay, so if I take 9 times 4, that's equal to 6 times 6. Okay, and so we end up getting that 36 is equal to 36, and that's a true statement, so we are proportional. Okay, this is a proportion. So, you typically would want to check the other sides as well and verify that, that this side is proportional to this side, and we also have a ratio of 3 halves. So let's go ahead and do that, and just to verify that, let me do right 9 over 6. So I'm going to use this length and this length, and I'm going to set up an equal sign and say that I've got 10.5 divided by 7. Okay, and I'm going to multiply this out, and so I end up getting 6 times 10 and a half, 10.5. Is that equal to 9 times 7? Well, 9 times 7 I know is 63, but 6 times 10.5 is also 63. Okay, and that's a true statement. So I know that that all three sides are proportional. So you do need to set up two proportions when you do this at least, especially with triangles. With a quadrilateral or a pentagon, it might be a little bit different, but that's the idea. So now I need to write. We know that they're similar. Okay, so I'm going to say this. I'm going to say that that my conclusion that I can draw is that triangle ABC is similar to triangle DEF. Okay, and that's because I can make that statement now because I showed that all corresponding angles are congruent. I did that here, and then I was able to tell that all three sides were proportional. Okay, and I want you to note how I write this. Okay, I want you to note that when I'm naming triangle ABC, okay, I also when I make my similarity statement, I have to put the letters that they correspond to. So A is my first one, and that corresponds with D. B corresponds with E, and that's my second letter. And then C is my third letter, and that corresponds with F. So that's really important that the order matters. Okay, so the order in which we write this matters. Okay, and so let's go ahead and let's just take a look at number 2. And number 2 is a lot easier to tell that these are similar. Okay, I don't have to really do too much work here, but I want to talk about my angles. Okay, and talk about what corresponds with what. So I know that angle P is congruent to angle W. Okay, and I'm just looking from here, my top left, to this top left. Okay, and I'm going to go around the figure to help not only to show that all the angles are congruent, but to help me name this. Okay, so then the next one I would say is angle Q is congruent to angle X. I know that angle R is congruent to angle Y, and then I know that angle S is congruent to angle Z. Okay, so I know that all my all my corresponding angles are congruent. Now let's talk about the sides proportional. So let me write proportional sides. Proportional sides. And so this one's a little bit easier because I can just take any of these because it looks like I have a rhombus here. This is a rhombus and this is a rhombus because all my sides are 3 in this and all my sides are 7.5. So all I need to show here is that, if I take the side length of 3 and divide it by 7.5, then that's equivalent. If I just think of PS is 3 and WZ is 7.5, then I can show that that's proportional to, PQ and WX. So, and all I need to say is that 3 divided by 7.5, okay? And since that's, the same for all of the sides, I just need to write it once, okay? If they were different, then I would need to write, the different things. So for my similarity statement, what I want to write, the conclusion that I can draw from this, the conclusion is that quadrilateral PQRS is similar to quadrilateral WXYZ, okay? And I'm able to name that pretty quickly, guys, just because of how I've written it like this. Okay, I'm just going to start on one end and go around my polygon. Same thing with the other one, but I want to start and put what they correspond with. And once I do that, then we can get this similarity statement. Okay, let's take a look at 3 and 4. And these are pretty easy. It's just setting these up. I know that these are... that these polygons are similar, and I can tell which ones are similar simply just based off of what we've got. So, what I do want to do is note that, A corresponds with E and D corresponds with H. Okay, so I'm going to go ahead and just write the proportion for that, which is 14/7. Okay, and I know that if these are similar polygons, then my sides are proportional. So I can go ahead and just set up a proportion. And so I used 14/7, and then I'm going to use 13 over x. So let's go ahead and just write 13 over x, and I set up my proportion, and then I can solve it. And I can take 14 times x and set that equal to 7 times 13. Okay, and let's go ahead and just solve that for x. So we get 14x is equal to 91. And so if I divide everything by 14, I'm going to end up getting an x value of 6.5. Okay, and so what I want you to see here is that, 7 is half of 14. Okay, 6.5 is also half of 13. Okay, so now let's take a look at number 4. And number 4, what I can see from this is that I've got, this is this isosceles triangle here. I've got corresponding angles that are congruent, even though this one's flipped on its side. Okay, so I'm going to set up the proportion of, WY and SU. Okay, and so I'm going to say 4 divided by x plus 5. And I'm going to set that equal to, and I have to use this number 3 and 9, okay? Simply because if I used 4 over x plus 5, I would get the same thing on either side, and I would just get x equals, anything. So I'm going to use 3 and 9 to set that up. And so I get 3 divided by 9. And so I'm going to go ahead and cross multiply here, and I get 3 times x plus 5. So 3 times the quantity x plus 5 is equal to 4 times 9. Okay, and so we can distribute our 3, and we get 3x plus 15 is equal to 36. Okay, and then if I subtract 15 from both sides, I end up getting 3x is equal to 21. Then I divide by 3 and divide by 3, and so x is equal to 7. So, and that's it. We're just using this concept of angles are congruent and corresponding sides are proportional to, using this idea up here to set up these types of equations. That's the ultimate goal. And we're going to learn about some particular things about triangles in the next couple of sections. So hope you've enjoyed this. It's been a lot of fun to make, and we'll see you soon. Thanks.